Okay, guys. So I think I've pretty well got this thing wrapped up. There are a couple of things I have left to do, but this machine is basically functional at this point, which is really all I need. I have a project that's due today, so I had to get this thing figured out. Boy, did this servo pack over here just give me all kinds of problems, and I'll get into that in just a second. But I want to make a correction from the last video. I had the enable for this relay over here for CR20. I think it's CR22 or CR23, one of the two. I'm using low speed only. It activates the K7 contactor down here. I had this set to be triggered off of spindle common and spindle enable. But I was somebody else has already done a full integration of this that is a professional. If you guys don't know, Mark from I think it's CNC Services or CNC Services Northwest. He's been super helpful on the forum, by the way. Thank you so much. But he said not to do that there. That that the common from here needs to jump through, because this voltage that comes into this is supplied by the inverter. It's not supplied by the rest of the system. This inverter outputs that 24 volts that's used for this circuit, and so it needs to jump through there. You can't use that. It needs to work exactly like this. I'm not an expert. I'm just going to listen to what they say because they know more about this than I do. So all I did was I just moved it over here to the e-stop. So the same place that the e-stop was turning on CB1, and CB1 activates this contactor. So I just did the same thing. I moved that wire that was in here in the last video in the spindle enable output. I just moved that over to the e-stop. I hooked up the limit switches. I got the limit switches hooked up. The limit switches on this machine are normally open. That's not good. I'm going to have to fix that. I'm not sure how exactly I'm going to fix it. I don't really want to have to replace the switches, but and I looked to see if I could rewire them as normally closed. If somebody knows how to do that with these particular model switches, please let me know in the comments. I don't know how to do it. So I looked at the switches. There was not like other terminals I could tap into or something, and that wire, the wire that comes out of here, the two switches are right here and right here behind this cover. They like terminate somewhere inside of this loop. I have no idea where. I need to get this project off the ground and running that I have due today. So I'll work. That's a tomorrow or later problem. So everything on this machine works at this point. The lube pump, I have to modify the PLC because the lube pump that's on here, this system assumes that your lubrication maintains pressure. The Centroid default PLC essentially assumes that it maintains pressure constantly, or has a float switch inside of the lube pump. Ours don't have that. We just have a regular pressure switch. And that pressure switch, I guess, says when the pumping is done or when you should stop. I don't really know, but it's just a standard pressure switch. And so the default PLC in here will not work. I do have the lube pump hooked up, or the output from that lube pump hooked up here into lube OK. Everything else on here, you guys can, I'll let you see what I actually have hooked up over here. Really not a lot. I'm not using a lot of inputs, not using a lot of outputs. This machine does so much more. There's the spindle blower down there. There's outputs that come out of that you can read, and statuses you can read. There's a ton more, but this isn't by no means a professional integration. I don't want people to think that it is, because it's definitely not. But all it has to do is work, and just has to work today. The encoders, the pin out that I put out last time, the hand wheel, I'll go over here to this side. This hand wheel will work if you use the same pin out that I showed in the last video for the spindle encoder. That will work for this encoder, but it will not work for this one. And the reason why is because this one, they wired it all crazy. They only used like 5 pins as opposed to 8 pins, and they have it hooked up in a very strange way. So I ordered a new connector, and that connector it's up in here somewhere. I ordered a new connector and a new and new pins, and I'll try to get that rewired and get this hand wheel working as well. So let's go ahead and fire this thing up, and we'll give you guys a little bit of a demo. I do use a rotary phase converter for my 3-phase power. I know, dangerous. You're not supposed to be inside electric cabinets, but whatever. It's fine. So yeah, you guys should see this Centroid controller is going to come up. That LED says 1 now. All the blinky lights are good to go. So let's go over to our control, and we'll go ahead and pop this open, see if we can make some moves, turn the spindle on, you know, that kind of stuff. So right now, I've just got the homing set to jog, so we're gonna work on that next. But if I turn on my MPG, I'll turn this to X100. If I turn on my MPG, I've got this right now is set to move this axis. You can see I'm rotating the hand wheel. It all works. This one currently does nothing. That's a bummer, because I love to have the manual controls on this machine. I think that's what makes it. It's what makes this machine so nice, such a joy to have. And one of the features I love the most about it is if I want to just do a quick job, I can, you know, come in here, grab the hand wheels, and just get to getting. Our spindle control. So we'll go ahead and turn this off auto, and check out our spindle. Our spindle. It looks like it's spinning the wrong way in that video. It's not. It's spinning the right way. Here, I'm gonna try to stop this. So you guys can see that it is in fact spinning the right way. Yeah. See. So to cut parts on a lathe, what you need is a spindle that turns and axes that move. So that works. All of it works. It works good enough. So let's talk for just a second about this damn servo drive, because this thing about killed me. Here are the old components. So I bought a new drive, because originally what had happened was the spindle drive, or the servo, blew up in this thing, and when it did, it took the controller with it. Like, it just, nothing would work. And I was never able to get it to work again. I got this. This is brand new. Look at this. This is brand new. Never been used. I think there you go. So that's a standard Yaskawa. This is the model of servo pack that's in these. I bought on eBay, bought a brand new one, thinking, hey, everything's going to be great. These things are kind of still available. There's a lot of them out there. They were using a whole bunch of Haas machines. They were used in these Bridgeport machines. The Sigma 1 drives, they're still out there, so you can get them. So I buy a brand new one, right? Super excited. Get this thing installed. My motor doesn't work right. It keeps throwing motor overload errors, and it's like, what do you mean motor overloaded? It's got a brand new drive in it, so I swap around. I go into my cabinet. I move the wires from here to here. Check the motor out. Everything's fine. It will auto-tune. No problems. It worked. So it turns out, in the old system, what had blown up was this part of the control board, of the servo drive. This board, so this board goes on top of here, and then this board goes on top of that, and that's your servo drive. Well, this board here in the old drive is bad. This one was bad. But in the new drive, this IGBT right here is weak. Something's not right with this brand new board here, and I don't know what it is. But it's not that it doesn't work. It's just weak. So I ripped this, the same version of this board, the brand new version, and then this board, which is the capacitor board. I put those on the old, and I'm pretty sure this is, and I'm not an electrical engineer, so I don't know anything about this stuff. But this is an IGBT, or the actual drive itself. that makes most of the magic happen, makes all the pixies move. So I took these two components from the new drive and the control board, and I threw them on the old IGBT. Wouldn't you know it, everything works. So anyways, well, I actually have a project. The project I have to do is I have to make sure this is concentric. This has got to be concentric. I have to take just a little bit out of the inside of that diameter. That's it. The whole reason I did this conversion is so I could get a small amount out of the inside of that diameter concentrically. So, you know, things you do for family. I love them. So I've got a go-kart I'm building for my grandson over there. It's or I'm putting back together. I've got this motor that I'm putting on it, and that part is a critical part that was in my way. And while I was working on the go-kart project, it blew up. This whole thing blew up, and you know, pushed me to get this Centroid control in here. I tell you what, the Centroid forum, super helpful. Everybody that I have talked to and interacted with at Centroid thus far, and the forum members have been amazing. They have been super helpful. Last tidbit. If you go on eBay and buy one of these servo pack controls, the digital operator, and you're supposed to have it to run the auto tuning on this, they don't come with this serial cable. You have to make sure you get one exactly with this serial cable, because what they will come with is not the serial cable. They'll come with a cable for the Sigma 2 unless you find one that has specifically this serial cable. And I have no idea what the pinout is here, no idea what's inside this connector. You can see it's a sealed up connector, so it's not like I can take it apart and get the pin out for you, because if I could, I would. I guess I could put a scope on it and check it out and see what the pinout of that is, but here's the thing. They tell you need to tune the drives. Listen to these things run. Do you hear any problem there? Here, let's go to the other one. Let's jog the other one. Here, we'll jog the X. Possibly. Helps if I turn off my MPG. Is there any particular reason that's going so slow? So anyways, I'm moving the X right now. You hear any noises? Any terrible stuff? No, you don't. Bridgeport's not stupid. And Rome and the manufacturers of the slave, they're not stupid. They have. The three things that auto tuning does is it tunes speed reference gain, loop time, and then position loop gain. Look, there's values pre-populated in the electrical diagram for all of them. They sound, work, run, drive just fine. You don't need auto tuning. You don't need to. Works just fine without it. So anyways, I have to get on to getting the rest of this machine set up, but when I actually go to make a cut and get something working, I'll show you guys what I'm up to. So thanks for watching.